Hi everyone, this video is about item response theory, and it's going to be a very quick introduction because there is so much to IRT. Just a quick overview, measurement history. So classical test theory is really based on Spearman's correlational analysis, and this was created in the early 1900s and has been the standard for measurement theory for a very long time. Item response theory was created in the 50s, and George Rush was one of the leading creators. Hence, we will be focusing a lot on Rush models and not some of the more technically complicated IRT models, which we'll talk about later. It's became really a lot more widely used in the 80s, but it's still just not utilized at large. Specifically in education and psych fields, it's a lot more popular and becoming a lot more common, but practitioners are still not seeing this as useful, and that is such a shame because it's amazing. So George Rush was one of the leading creators. Lineker studied under Rush. I just think this is cool. Dr. Kathy Green studied under Lineker, and I studied under Dr. Green. So it's kind of cool to see like the direct connection and why I am so obsessed with Rush models probably. So when we think about classical test theory and IRT models, classical test theory is based on X being the score that we have is equal to their true score plus some error. We don't do a whole lot with error, but all the assumptions are about error. So essentially, we are assuming that the score that we have is their true score. IRT models, specifically the one parameter model, is considerably more complicated. But here's what happens. So we have a very simple table of 5 items and 5 people. And we're going to organize this table based on personability and item difficulty. So when we think about personability, in this example, we are looking at, did they get the item correct? So this is an ability test, like intelligence. So how much do they know about this math thing that we are giving them, this math test that we're giving them? So we can see that person 1 got all 5 items correct. So they have the highest ability of these 5. Person 4 got these 4 correct. Person 3, person 2, and person 1 only got item 5 correct. So they have the lowest ability. A lot of times what we are talking about though is endorsement of a construct. So this might be an agreement scale. So instead of a dichotomous you got it right, you didn't get it right, it's more about how much did you endorse this concept, like stats anxiety, and maybe it's an agreement scale. So it's a 1 to 5 agreement scale, so person 1 would have all 5s, and person 5 might have all 1s, meaning they disagreed that they had stats anxiety. Person 1 had the most stats anxiety. So conceptually it's the same, but it's a little bit easier to look at with correct and correct. So we can see that we can easily set up who has the highest ability and who has the lower ability. But what this also offers us is that we can see item 5 was the easiest. Everybody got item 5 right. And item 1, only one person got item 1 right. Specifically, the person who had the highest ability got item 1 right. Everybody else got it wrong. So we can see item 1 is the most difficult or the hardest to endorse if we were talking about stats anxiety. Item 5 would be the easiest to endorse or the easiest to get correct. It's that easy. That is what these models are based on, that we say, okay, this makes sense, and it allows us to look at items and persons in the same manner. All of this is based on logits. So logits are a transformation that we use in mathematics all the time, and it's like a favorite in statistics. But what it's doing is it's looking at probabilities, and it gives us the log odds of how likely something is to happen or not happen. And IRT models are not linear. So classical test theory is based on correlation, which is taking the line of best fit for that data set. IRT models say this is the curve that we believe is true, and it fits the data to the curve, which is very different. We can see that the curve never touches 0 or 1, but it's going to get really, really close. So it's a lot like a normal curve in that manner. But what it's doing is it's describing the probability of a response on an item based on your latent trait ability. So if we were talking about your, knowledge on the math test that we're giving, or your endorsement of stats anxiety, that would be that latent trait ability. And what is your probability of response on an item based on that? So here's an example of an item characteristic curve, or an ICC. And what it's doing is it's plotting the curve with this probability. So in this example, we'll look at 0 would be the median ability or proficiency. So about half of the people would be kind of right here in the middle. And we can see we would go over here. And so it's about 50-50 on this example curve. So we can see that about 50% proficiency, so people right in the middle of our ability level, have about a 50-50 shot of answering this item correctly or endorsing this item. And what's really cool is that all of these items differ. So the curve stays the same, but the ability level changes. That probability of response changes. So if we look at the 50-50 shot across these 3 items, so green, brown, and gray. If we look at the 50-50 shot, we can quickly see that this green item is the easiest. People who have lower abilities or lower endorsement of the construct have a 50-50 shot of getting this item correct with a -1 ability. For brown, that's our 50-50 shot. So we got people who are right in the middle of this trait or ability level have a 50-50 shot here. And people who have a higher ability level or higher endorsement of the construct, for this item, that's where they have a 50-50 shot of answering this item correctly or endorsing this item. So we can also look at this in a slightly different way. So people who have a mid-level ability, so they are right in the smack middle of this ability level or endorsement level. If we look right here at this gray item, they have a 10% shot at getting this gray item correct or endorsing the gray item. If we go up here to this green, we have a predicted almost 90% of them getting this green item correct or endorsing this green item. And what that allows us to do is it uses logit positions, and we can put all of these on the same scale. This is my favorite part of IRT models. And so we can take all of these are items, and we can literally put them on a ruler or a scale. So it's the same concept of this ruler down here, this is our ruler over here, and we put them in order. And so we can map them with persons. So this side is all of the persons in the sample, and these are all of the items in the sample. And what we can see is that most of the persons are grouped right here, and we have a lot of items right here as well that match them. So these items are helping us differentiate and identify this group. But we also have some people who have higher levels of endorsement or higher levels of ability. And we have items up here that are matching them. So we have items that are measuring and differentiating this higher level ability group. And the same down here, we've got some with some lower endorsement or lower ability. And we have some items right here that are helping us map out and differentiate them. So this person has our lowest ability level, but we still have something that is helping us see that kind of matches their ability level. So they would have a low probability of getting any of these correct or endorsing them, but they're going to probably endorse this one and this one down here on this lower side of the ruler. And the same, this person way up here would have a very low probability of not endorsing all of these. We would expect them to get all of these correct. And then these two items right here would help us differentiate that higher level. So take a moment and pause and kind of reflect on the major differences between classical test theory and item response theory.